Welcome back to this lesson. So here today we want to look at iterative development. Okay, so how to overcome waterfall failure in agentic product management. So in the first lesson, we've looked at the 6 layers of agentic AI product management. So the 6 layers of agentic AI system design and how you can actually design those layers one after the other. Look at the opportunity layer. We look at the architecture layer, we looked at the data layer, we look at the intelligence layer, we look at the governance layer, and then we look at the user interface layer, and then we look at other layers, 6 of them. Okay. So iterative development overcome waterfall failures. So this is how you move from big bang launches to continuous prototyping. So big bang, that's a big, they call it big ball of mud, where you just build something at once and then you just deploy it. And then after deployment, you are finding out that the system fails. So you'll be entering a big ball of mud by designing that kind of architecture. So iterative development is better than waterfall. Waterfall is just get the business requirement and then go ahead and develop everything from A to Z and deploy it. And then after deployment, you are finding out that the application does not actually solve the problem, does not meet the business standard. So that is waterfall failure. So we don't use the waterfall method in system design. In technology, we use iterative development, which is agile and lean approach. Agility is applying lean to solve software problem, applying lean approach Scrum to develop a system. So agility is iterative development and iterative delivery of a software product. So as a product manager, you must also implement iterative approach. You must use agile approach to deliver your product. You must not deliver a product that will fail at the end of the day. You must make sure it is delivered iteratively and it is checked iteratively whether it meets the standard as they continue. So you can also quickly determine in the first delivery that this product, what they are what the software engineers are delivering does not meet the business standard. It does not work according to your design, or it does not accommodate change, and then you can easily revert and redesign, look at the product again and call the software engineers into, to align with you, to align with the design that you have. So iterative is very, very important. It's and able to deliver a working application that will still accommodate changes if there's any change that the business owners want to implement. So to follow the iterative development method, you have to prototype first. Okay, build a low fidelity version to test core intelligence. So instead of, if you want to build 10 agentic system, for instance, instead of just delivering the 10 of them at once, you deliver the core layer, the core intelligence layer, which is the framework, and then you start adding agent to it. You can add one agent and see how it works. Then you can add 2 agents and see if it works better. Add 3 agents. Then you gradually increase until you get to 10 agents to measure the level of or intelligent or level of value that the agent can add to the system. So prototyping is very, very important. That is why we have MVP, is it model or viable product. The MVP, you deliver maybe 20%. You deliver 20% of the product and then you let user test it. So if they test it and it's working well, if there's no complaint, no change, you continue and then build up to 50% and then deploy it again, 70%, 80%, until you reach 100%, where the product is fully mature and working fine. And then in prototyping at MVP is where you can gather users feedback, whether the user interface is good, whether your design is actually solving people's problem. So prototyping is very, very important and you can use MVP for that. So delivering a certain level of your agentic system. Maybe you can deliver with 2 agents first to test out what the user will say and to collect users' feedback. Then collect failures. So you are not using MVP just to, deliver gradually. You are using MVP to collect failure. You deliver the system to the user, maybe B2B or B2C, and then you collect feedback from the users. So collect failure, success, and everything. Identify where the model hallucinates or where the model fails to respond or to follow instruction, where the model failed to implement policy and implement under guardrail, where the problem, where the agent fails to predict, where it will predict, or whether it is predicting wrongly. So these are very, very important. You must collect this user feedback, failure feedback, very, very important, not only success feedback. Then you refine the data. After collecting the failure, you act on the failure, and then you use the failure to refine the data. Use real world failure cases to improve the retrieval set, so you can go back to your retrieval augmented generation. That's why we have a database. I talked about the data layer, so I should have discussed RAG database, but RAG database is called retrieval augmented generation database, where historical knowledge of a particular company are chunked, okay, and embedded. They are chunked, indexed, and embedded as a vector database, and then you can use hybrid search. The LLM can use hybrid search, or maybe semantic search or keyword-based search, to retrieve information from the system and use it to augment any output that it wants to give you. So it's stop, it prevents agentic system or AI system from hallucinating, from saying they can do what they cannot do, or from giving you wrong instruction that is not correct. Because or retrieval augmented generation refine the output of the LLM to make sure it is accurate, and it give you information based on your company details. And then we have dynamic deployment. So this slowly increase agent responsibility as confidence grows. So dynamic deployment increase agent responsibility as is where you increase agent responsibility as confidence grows. For example, you don't deploy 10 agents at once. No, you can deploy 3 and measure and collect failure feedback, and then you refine the data, and then you deploy again. So if all the feedback we are getting from those 3 agents are success feedback, then you know it is time to add another agent. Then you can add another 3, then deploy it again, collect feedback. If there's any failure feedback, then you need to refine the data again, and then you redeploy, okay, and collect. If all this feedback are success now, then you can add the other agent until you continue gradually until you deliver the agent 100%. Okay, so maintaining the agent's opportunity tree. How do you maintain agent opportunity tree? So opportunity tree of an agent is, from the beginning, the problem your agent is solving, and the particular particular flow that the agent want to implement to solve a problem. So prioritizing 6 category of AI driven business benefits. So opportunity tree are the value that the agent will actually add to the business. Okay, so these are the 6 category of agentic system opportunity tree that you can use in your, as an agentic product manager. We have augmentation. So this is helping human make better data-driven decision. So instead of human assuming and giving assumption, or giving a feedback that is not grounded on data, on company data, agentic system is using RAG database, is giving information based on the RAG database, based on the historical data, based on the company information, and it is operating within policy and governance. This is why they said agent will take the place of human. Yes, if agents are properly built, with guardrails, governance, and policy, with all the knowledge, it will outperform human being. Okay, so most of the employers in company maybe BSc holder. So if you have a procurement manager that is a BSc holder, he doesn't have the knowledge of MS, he doesn't have MSc knowledge, he doesn't have PhD knowledge of procurement. So if I train the agent with a PhD level knowledge of procurement, and I give it and I design it within a bounded context, giving it governance and guardrail, it will outperform what a BSc procurement manager will do, for instance, and it will take the place of the manager. So that's why we said AI is dangerous. It can take the job of a human, you understand? Because most human, they don't implement, they don't work within governance. So we have people that just want to cheat on the company, instead of saying, okay, this contract, we are going to pay this supplier so maybe $3,000. So maybe because they want benefit, they can say, okay, 3,500, so that the 500 can go to the pocket of the procurement manager. But if you have an agentic system that is doing it, agent will never cheat you and say 3,500. No, because agent can even negotiate better than human. Agent can negotiate with the, with the contractor or the supplier to reduce the price, which some human may not be able to do. You understand? So augmentation, helping human make better decision. It helps CEO, CTO, manager make better decision, data-driven decision. And then we have personalization. This is scaling one-to-one service for millions of users. So personalization enable agents to solve a particular problem. Okay, if you are building for a procurement manager, you must make sure that it is specific to the task of the procurement manager, and it is meeting the need of the procurement manager one-to-one. So agents have owners, and it must know the owner, solve or must be able to do the work of the owner, and it must meet the owner's standard. Okay, so scaling one-to-one service for millions of users. So you cannot use one agent for all departments. Every department have their task, and they must have their specialized agent. Then innovation, creating products that were impossible before AI. Agentic AI makes a lot of things possible. It makes a lot of automation possible. There's some automation that ordinary workflow like Power Automate, Logic App cannot do, which agentic system can do. So it brings innovation into software system. For example, you can just sit here now and give a Claude Code an instruction to build an entire application and deploy it on your behalf, which it will do and deploy it, and which you yourself, a project that can take you like 3 months will take the agents maybe like 3 hours to build and deploy. So that is innovation and creativity. Agent bring creativity and innovation where to tasks that were initially impossible or that normally take longer to do. Then we have convenience. Agents reduce friction in the user's daily workflow. So there are some tasks that will take you 6 hours to perform. That agent will just perform maybe under 30 minutes or 1 hour. So it reduces convenience. It helps you to deliver faster. It helps you to do what normally you will give a contractor to do, or what normally you will handle to a consultant to help you do. You can do those tasks on your own. All you need to do is to give an agent instruction, as long as it is built for you, as long as it is built with all your tasks and knowledge and using your database. You just give it an instruction, and under few minutes or seconds, it delivers to you what will normally take you maybe 3 days or 1 week to achieve. And then you can use your other time for strategic decision and thinking and implementation of what AI cannot handle. Okay, so emotional engagement, building trust through empathetic interaction. So agents are also empathetic now. It's not they will say some human beings are even very wicked. Some human beings don't operate within guardrail. they violate system, they violate company rules, and they go outside the company policy because maybe at that particular time HR cannot be with everybody. HR cannot sit with everybody. HR sit in their department, other employees sit in their department. So in their department, they can violate company policy that the HR will not even be aware of, that the security team will not be aware of. Agents will never do that. Agents are emotional. Agents are emotional because in my CADABA study, in my CADABA design, I have what we call the adaptive thinking. Agents can think adaptively because they use recursive learning. They use neural network. Neural network is just like the entire human cognitive system. So when you design an agent based on neural principle, based on recursive learning, neural mathematics, you are this is just like designing an entire human brain that will operate ethically, without violating any of the policy or governance that you have designed for it to perform. So how many human beings there are outside there and trustworthy? Okay, because even when you employ, when HR employ people, they place you on probation for 3 months. If within those 3 months you violate the company this thing and they caught you, you are going. You understand it? They place you on probation because they know that they don't trust you yet. And of course, a lot of people are not trustworthy. They employ a lot of people for some particular task. They cannot do it, or they do it wrongly and deliver. So, how many manager or HR will be able to monitor what individual people are doing in the business? So, or how many manager will know, how many HR will know whether a manager is abusing, a worker that is working under them? So these things are not mostly in place. Even when there are cameras these days to look at what people are doing in their respective location, people still don't care. Nobody is monitoring the camera, or nobody is collecting information from the camera, except where you have a solid system where there is computer vision to process those things and retrieve information from whatever things. But how many companies are actually implementing this? So agents can engage with you emotionally, empathetically, to solve your problem and meet your goal than most human beings. Automation, removing routine, repetitive, manual work. So automation, agent can automate many tasks that normal workflow cannot do. So they can remove normal routine. They can remove where, pattern operation, everything that you do repetitively, like everything that you do, maybe an operation that you do every day. You can automate them, and agent can do them, if you give them full level of autonomy, 100%. But there are some tasks that you must not allow the agent to have 100% autonomy. And there are some other tasks like analysis, data collection, data engineering, or other automation that you can allow the agent to have full autonomy. Okay, so these are the 6 categories of agentic system opportunity tree that you can consider as a product, agentic AI product manager. Then we have calculating the real cost of automation. So automation can be very expensive. You must calculate the real cost. Okay, you must determine if the business can afford the agent. Okay, and then you must determine the need for multi-agent system. If you have a need that one agent can solve, you don't need to design 3 agents or 2 agents or 5 agents to solve the problem. Okay, so real cost of token usage, cost of platform, cost of database, cost of deployment, operation, cost of engineer that will even develop it. You must consider all this in your system design. So development and inference, initial build plus ongoing API cost. So you must develop the cost of initial build, develop what it will cost you to hire consultant engineers that will build it. Okay, and develop also determine the API cost of token usage, how much LLM will the agent consume per month, per day, per week, and so on and so forth, and determine whether the company can afford it or whether the cost is worth risking. Maintenance, you must also determine how ongoing monitoring for drifts, Drift is, when the agent deviates from telling the truth, when the agent changes from what is designed for, or when it changes backward. Let me just use backward. When it's no longer accurate, it drifts from initial accuracy to less accuracy. So that is data drift. It happens in LLM. That is the cause. So when LLM hallucinate, they are drifting. When machine learning gives wrong output, is because of drift, maybe data change, or there's data drift, and so on. So ongoing monitoring for drift in model performance. You must measure negative changes or false positives in your agent performance. Very, very important. And then risk mitigation. So the cost of potential hallucination damage. This is why human in the loop is very, very important. So you must mitigate risk. That's why you should implement guardrail, policy and governance. Security team must be involved. You must build your agent within the boundary of the company. You must give them role-based access control, least privilege. You must not expose data that must not be exposed. You must hide personally identification data. You must also, implement what is called the encryption. Data must be encrypted at rest in transit, and even in the database you must implement encryption. And then you give role-based access control, least privilege, anonymization and minimization. Very, very important to mitigate risk or exposure of data and hallucination. So to prevent hallucination, you can use you can implement few short prompts or chain of thought or tree of thought, okay, to do that. So when you give initial prompt and then add examples, that is few short, it prevents hallucination. If that cannot solve the problem, then you must build a RAG database where you collect historical data, chunk and index them, and embed in a vector database, and the LLM can use a retriever can retrieve data from the database to add to the context that it has earned, to also prevent hallucination. Okay, and then we have human in the loop. So time experts spend reviewing and correcting agent work. So cost of risk mitigation. So if you are building a RAG database, for instance, you will pay for the database, you pay for the engineer that will build it. That's another cost. And then if you are implementing fine-tuning is normally known for very, very expensive, because you have to evaluate, you have to do everything, and that fine-tune the LLM. That's another cost. So you have cost of development and inference, engineer cost, delivery cost, and so on. You have maintenance cost. There must be continuous observability. So you pay the site reliability engineer that will continue to monitor the activity of the agent, to monitor drift, and so on. Risk mitigation to prevent hallucination. You determine the cost of RAG database, cost of fine-tuning, and so on. Then human in the loop. You have to hire a domain expert, time expert. So this is the time expert spend reviewing and correcting agent work. So based on this time, if you want to have a human in the loop, an employer, maybe a procurement analyst that will stay with the system 24/7 and be monitoring the activity, handling what the agent cannot do, that will be an employer. So you also determine the cost of human in the loop, so which is not actually because you already have this human in the loop, you have these employees, you just want to automate their tasks so that you can reduce employee or achieve maximum effort. So you pay for an expert that will also be working as an human in the loop for the agent. So these are the real cost of automation that you can determine in your management of agentic system. Then we have human and AI strengths. So how is AI stronger than human? We have said that agentic system can replace human. Yes, they are empathetic. Yes, they are faster than human. Yeah, they can do complex work that human cannot do. Yes, they can, generate more revenue than human. They are stronger than human. They are never tired. And if they are built well, no hallucination, and they don't cross the guardrail that you have defined for them, which human can normally cross. Yes, that makes them better than human in some cases, but in other cases, they are, other human have their strength, agent also have their strength, and both of them also have their weaknesses. Okay, so let's look at most of this. So the first one is scale. In terms of scalability, agent can process millions of information of record per minute, per seconds, per minute, or per hour. Okay, so while human strength is just the strength of AI strength, that's AI strength. They can do complex work within minutes, within hours, which will take human 3 months or 1 year to achieve. Then human strength here is conceptual judgment. Human can reason, beyond what the agent cannot do. Agents use mathematics, they use logic, they use principles based on scientific research and approaches, which are still artificial, which is why we call them artificial intelligence in the first place. But human, they are natural. So human can see, can think in the natural sense, and see what the agent cannot see naturally. Of course, we are still a universal being. We are created by, we have blood and water in our system, and we know what is realistic in terms of race and non-race, but agentic systems are just general. They operate with algorithmic reasoning, logic, and mathematics. So which is uh what they use, and the human uses common sense and judgment, human judgment. So in terms of creativity, agent can recognize many patterns and combine the pattern accurately. So human being cannot do this. Then for human, we have originality and ethics. So every human being is unique in its own way. Okay, if some human that are not ethical, they are still unique in their own way. They are unethical because of their background or the way they are brought up. That's why you see some people tell lies, some people tell you the truth, some people are intelligent, some people are not, and all that. Some people, everybody just have their own way. You can see somebody who doesn't go to school at all succeeding even more than the person that goes to school. So that is originality and ethics. So human are original being, and that is why it is not good for you to change yourself or to what did they call it, to feel you want, because you want to feel among or you want to belong, you now start changing your behavior to fit a particular situation or a particular people or peer, because of peer pressure. You want to shift from your originality, from your original self and reasoning to accommodate maybe your friend, to fit into the environment, and that's no, I don't believe in that. Be original, be yourself. Okay, and if you are not ethical from beginning, you need to learn ethics and how to be ethical. Human behavior are learnable, so you can learn to be empathetic, you can learn to behave well, and you can learn to judge rightly. So agent uses pattern combination, human uses originality, whether organized or not organized. Okay, agent in terms of consistency, never get tired. Agent never get tired or bored. They are machines. They work continually. They do not tell, they don't tell you I'm tired, except maybe your token usage finishes. That is when the agent will be tired. But as long as you have token, there's token to use and consume to do the work, they never get tired or bored. But as a human being, we can get tired, we can get bored. For example, I got bored of my data engineering work that I was doing with a consultant company, and I resigned because it no longer meets my value, no longer meet my standard, and I'm just there, just forcing myself to go every day. So I was tired of going, and then I resigned to start my own business. So that is, I got bored of that company, the operation and the system. But for agent, they don't experience this. Okay. So human have the capacity to manage high ambiguity. So human are ambiguous. You can never tell what a human being is thinking because you can only see the face, you cannot see the heart. So you may think that somebody is your friend, whereas inside them, they know they don't like you and they know they are your enemy. So you can think somebody is your enemy, maybe based on what they tell you, but inside them, they know that they like you or they know that they will never hurt you. So that is human being. Human being manage high ambiguity. We are ambiguous. We cannot be predicted. Human being cannot be predicted. You can have a patient in the hospital as a doctor, and then, oh, you can say, okay, based on based on maybe whether the person is responding to treatment or what, oh, you say this person will get better. And maybe the second day, the person just spy, the person is gone, and you are surprised that, oh, but he was actually getting better yesterday and all that. So that is ambiguity. So human can manage ambiguity. So sorry for using that example, it just come to my mind. So that's a natural example. So there are some other things. You cannot predict a human being. That's just it. Speed, seconds per task. So agents can work very within a minimal latency. They can perform and achieve a task and deliver the results, while humans are empathetic and relationship building. So human can build relationship. Okay, we have many type of human being anyway. We have those that are empathetic and those that are narcissistic, those wicked narcissists. They also have their own traits, but they also have their own good part to their friends. But if you are not their friends, they will hurt you. So empathetic, let me say most human are empathetic, and most can build good relationship. Even those narcissistic people, they still build good relationship with people, maybe their family member or people that they like. And you have some manipulators that will manipulate their way to get what they want, whether it is right or wrong. So human beings, there are variety of human beings, many with their strengths and their weaknesses. Okay. So horizontal versus AI or vertical opportunities. So remember, what we are still discussing here is opportunity. How do you determine the opportunity of an agentic AI system? So horizontal opportunity and vertical AI opportunity. So in a company, solution like writing assistants or generic chatbots that work across industries. So vertical opportunity can be considered like a workflow. We have vertical opportunity. So workflow that you can build for company A, the same workflow work for company B, the same workflow for company C. That is a horizontal. So you can build a one workflow that you can integrate with many company, whether it is finance, HR, whether it is finance, whether it is energy company, oil and gas, whether it is maybe trade, whether it is healthcare, agriculture. The workflow can just work across. So that is an horizontal solution. Then vertical, deeply specialized agent for banks. So these are specialized agents that are meant for own particular company. For example, you have finance agents or you have bank agents that's meant to work with bank, not with energy or oil and gas or healthcare. Then you have healthcare specialized agents, you have law specialized agents. Then inside these industries, banking industry, you have several agents. You have finance agents, you have a trading agent, you have a HR agent, you have IT agent, IT operation agent, you have all agent type. And then in healthcare, there are department in healthcare. You can have a brain expert, you can have surgical expert, you can have they call it endo. Those even in body system, we have people that focus on endo. That's they focus their own discipline is internal organ. We have gynecologists with doctors with a reproductive system, and that we have optical, or we have optician which focus on eye and everything. We have the people that focus on brain and everything, and then we have people that focus on your skin and physiologists and everything. So if you are designing an agent for all these specialists, they have their own specialist agent as well. And then we have law agents. So every domain have their own vertical agent. Then we have CADABA strategy. So CADABA strategy focus on vertical business process. So what CADABA does is just to give you a framework, okay? Just like a framework. You can deploy the same framework for bank. the same framework for healthcare, the same framework for law. That is it is just the brain. Okay, so it's the agent that will now decide. So it is the agent that you attach to the brain that will decide how the brain will perform. Okay, so or for example, if you have what is training now is multidisciplinary studies. So you have somebody that have the knowledge of software engineering, have the knowledge of security engineering, have the knowledge of maybe HR, have the knowledge of banking, and then I just decide to work based on the situation. Well, if there's software engineer, I do it. If there's AI engineer, I do it. If there's data engineer, I do it. If there's machine learning operation, I do it. If there's data analysis, I do it. So I work based on, what is at hand, based on the contract or the project at hand. So that is how CADABA does. CADABA work based on the agent that you have attached to it. If I attach a banking agent, it will operate with banking knowledge. If I attach an healthcare agent, if I deploy an healthcare agent on it, it operates with the knowledge of healthcare system. So that is how it works. CADABA is a framework. It's my framework that I designed for deploying. It serves as a platform for deploying several types of agents. So it operates a vertical business process. Sorry. So vertical is a platform that works for many organizations, not horizontal. Then prioritize by impact. So impact and feasibility. What is the impact of this agent in a business? Or what is the feasibility? How feasible are they? Is it possible? Can it achieve the goal? Can it solve the problem? So that is impact and feasibility. The first one is user impact. How much time or pain is reduced for the end user? So if I'm designing something to solve people's pain, to take away the pain of people or to ease the stress of people, and then I deploy it and give it to them, and then it's adding to their stress, it's doubling their work. So there's no impact in that situation. So it must remove the pain of people, and it must optimize their workflow, their process, and then not cost them too much money. It must reduce the time of work and add value in terms of even financial benefits to the system. Then technical feasibility. Does the required data exist in a usable format? So technical feasibility, you can't design an agent based on an empty database. Okay, if you must connect the ERP, SharePoint, RAG database, historical database, company information that will ground that will be a ground, or that will be a foundation for the agent to operate, to reason, and to give you information within those bounded data sets design. So technical feasibility, you must determine whether the company has data to ground the agent, and the strategic alignment. Does this agent build a long-term data advantage? Does he have a long-term data advantage? Is it beneficial to the company long-term? Is it what the company can adopt long-term, and it will generate profit, optimize their system, and continues to add value, not what we call them problem? And then you must look at regulatory risk. How costly is it if the agent makes a mistake? So you must also make sure that there are particular risks that the agent must never take when it's, or anything that involves financial operation, anything that involves payment. So it must be bounded, and it must be mitigated. And most of those tasks, when goes beyond certain payments or certain amount of money, must be handed over to human love to handle. So these are impact and feasibility that you can look at in your agentic system design. So I think we'll stop here for opportunities. So we've looked at various opportunities and the strength, and we've looked at real cost and the opportunity tree. Okay, so this is where we'll stop for now. Okay, and we can come back next time. So when we come back next time, we'll be looking at how you can balance quick wins with long-term advantage. So thanks for listening, guys. If this is your first time of joining us, please kindly like and subscribe to this channel. Bye. See you.